open up the antclips.fxs. Let's go to the Scenes folder, Ant Clips. Now before we start integrating this SmartMovement programming into our animation, the first thing to do is define our stride length. I know. We already defined it in the animation files by animating the objects the same distances in each clip. What I'm talking about is defining how far the main bone has to translate to keep the feet proper to the ground inside the cycle. If we have that length, we can synchronize our clips to always play the correct speed no matter what distance or direction the main bone moves. So we're going to use an expression in the Command tab called Path So Far. Let's go to Command and create a new variable. We're going to call this variable ant distance. Go to Expression and pick out Path So Far. What Path So Far does is it takes an object, in our case, main bone, and it measures it from the beginning of the animation to a frame. And our frame is the current frame, which is now. Right click to add that and turn on debug. Right now it has gone 0 distance because we are at frame 0, so it's measuring 0 meters. If we know how far one cycle of a walk can move the main bone along this path, any path we choose to animate, if we divide that by the distance of our walk cycle, we should get a normalized value that lets us drive the time factor. So what is this stride length distance? Well, let's measure it and find out. Let's go to Compose and mute all of the tracks except for the walk forward track. Go to a left view and go into animate mode. We know that our clip is 32 frames long on our walk cycles, so go to frame 32 and grab the main bone and translate it on Z. So as one walk cycle is playing, 32 frames worth, we are translating our object forward. Now you take a look at the legs, and if the legs are drifting forward on frame 32, move the controller backwards. If the legs are drifting backwards on frame 32, move the controller forwards until your feet are glued to the ground during the walk cycle. This looks pretty good right now. So on frame 32, the distance that main has moved is our stride length. So go back into Command, and you take a look at that number here, 1.189. That's the number that we need to divide by our measurement to get our 1 unit per animation cycle. So in that case, let's just punch that in, divided by 1.189010. Hit enter. Oh, what did we do? We forgot to add the divide. There we go. So now we get 1 unit. So 1 animation cycle is 1 unit of time being animated, which is 1 piece of distance. So we've converted distance into time again. Translating 1 unit will play 1 cycle of the animation, and if it translates faster, the animation is going to play faster, keeping the feet on the ground. This expression will tell us how to cycle an animation over distance, but we haven't done the actual cycling yet. So we need to add another variable, and we're going to call it mix time forward. This variable is going to use an expression called clipInstTime. So we're actually going to use our ant distance to drive how time is played through a clip instance. Our clip instance, if we go into Compose and look at that, is called walkForwardInst. So into Command, in quotes, forwardInst. We're not going to measure to the current frame, which is shown right here in the second. We're going to use ant distance instead. What that does is when we right click on this, we will be telling Mix Time Forward to take that clip instance and blend it 1 unit every time we translate 1 unit's worth on the main bone. So right now it looks good. So let's make this cycle a little slower, play a little bit slower. We'll lengthen it, go to the dope frame, left mouse click on that object on the main, it's translated to 100 frames so it plays even slower. Well, the object is moving slower but the cycle isn't. So what's going on? If it's not working for you, there is one caveat we didn't discuss, which is execution order. We're dealing with blending animations within Compose, so we need to set the command execution to motion instead of before or after IK. That way it waits to execute after it is checked where the final motion data is. Now our expression should work. So let's change this to motion and the ant distance to measure the motion for the animation as well. So now, as we scrub along, the feet stay synchronized to the ground, glued to the ground, no matter how slow or how fast our animation plays. So if we play at 10 frames, he walks fast on 10 frames. Set it to 100 frames. He's going to play 1 unit of animation over 100 frames. So let's duplicate this 3 more times for the other directions using the multiply key on the keypad. So mix time forward turns into mix time left. Take a look at walk forward inst. We will change that to walk left inst. Let's duplicate that again. Walk back inst. So mix time backward. Duplicate that again and walk right inst. So now all of these clips are being driven by a single variable. No matter how long or fast the translation is, the feet will stay grounded on all of the clips. So let's just right click and delete the main bone and save this scene. Let's go to File and save the scene as and underscore combined.